Welcome everybody. We got an interesting question. We got three circles in this fashion, and if I were to take this one as C1, C2 and C3, there is a common tangent, a direct common tangent between C1 and C3, and we are expected to find the area of this triangle. Now if I were to take this as A, B and say C, then clearly according to the theorem on tangents, a line drawn from the center of the circle to the point of tangency will make an angle of 90 degrees. So if we were to consider this triangle, this is actually a right triangle. So that is the first observation. The next observation is we have been given the radius of C1 to be equal to 4 units, the radius of C3 to be equal to 5 units. Now we are not given the radius of C2 and we don't need it. So what I would like to do here is, since I would like to state this, since there is a direct common tangent between C1 and C3 by the geometric property of direct common tangent between circles, we know that, so we are actually invoking this property. We know that the length of the tangent AB is equal to 2 times root of R1, which is the radius of the circle C1, and R3. So I'll mention it here. R1 is the radius of C1 and R3 is the radius of C3. So this would imply my AB is equal to 2 times root of 4 units and 5 units. So this is equal to 2 times root of 4 times root of 5, which is equal to 2 times root of 4 is 2 times root of 5, which is equal to 4 times root of 5. So this is the length of AB. So let me go back to the figure. From the figure, as I've shown you this figure, we have got the length of AB to be equal to 4 times root of 5. Now the radius of C3 is given to be as 5 units. So we can actually apply Pythagoras. If you were to see this figure, Pythagoras can be applied. So since triangle ABC is right angled by Pythagoras theorem, we know that. So what do we know? We know that AB squared plus BC squared is equal to AC squared. AC squared. Now we wanted to get the area, right? In fact, now you may be wondering, why am I getting this side? Now actually this problem is the first part of a huge problem. So there is no harm in getting AC as of now. But outrightly, we can actually, if you were to see here, this is a right triangle, right? It's a right angle triangle. So now since that I've got AC squared, let me calculate AC. So AC squared is equal to AB, which is 4 times root 5 squared, and BC is 5 squared. So this is going to be 4 squared 5 plus 5 squared. I can take 5 out, so this is going to give me 16 plus 5 is equal to 5 times 21, which is my AC squared. So AC is equal to root of 5 times root of 21, and we can't do anything about that, so let me write it as square root of 105. So this is the value of AC. As I mentioned to you, we would be requiring this in the next question, but as of now, since I've got AB, I know BC. So because if you were to view this is how the right triangle looks, right? I got the base, I got the height. So let me write that down. So therefore area of the triangle ABC is equal to half times base into height. So half times my base is, I hope you are able to see this right triangle. So the base is 5 units and the height is 4 times root 5. 4 times root 5. So 2 divides here 2 times. So 2 times 5 into root 5, which is equal to 10 times root 5 square units. So this is the area of triangle ABC. So that completes the solution for this part of the question, and we were able to do this question because of this property. So have that in mind. So this is a lovely question, and like, share and subscribe to our channel until we meet again. Thank you.